Hello Matrix and welcome again. Today we are looking at finding the derivative using first principles. Now, this should be guaranteed marks in your final exam because it's not too difficult. So what I want to do is I want to start first by showing you the ingenious method that Newton found in order to find the slope at a single point on a graph. So we know that when we want to find the slope between 2 points, we can do that by using change in y over change in x, right? And that gives us the gradient. So Newton said, well, okay, I'm going to find the graph between the slope between 2 points. So he called the first point x. Well, he knew the x value was x. And so the y value would then be f of x, because remember, f of x is the same as y. So, for example, if I was to write y equals x, sorry, f of x equals x squared if I was to write f of x equals negative x squared plus 2x, I could write that as y equals minus x squared plus 2. So this f of x basically just means y. So he said, well, if this point here is x, then my y is just f of x. He said, well, let me take a point h distance away from that x value. So if the distance was, say, h, let me take that point. Okay, and so he's going to call this point x plus h, because if it's h distance, the x will be just x plus h. And so he said, well, if this point here is x plus h, my y will just be f of x plus h. And so he said, well, if I find that slope, I could then just put it into a formula. So I could just say change in y over change in x, because I've got these 2 points. So he said, right, well, my change in y is going to be f of x plus h minus f of x. And my my change in x is just going to be the x plus h, which is the first x value, minus the other x value, which is x. And so when he simplified that down, he said, well, I would get f of x plus h minus f of x over x minus x is x, and that's just h. So that was the first bit, but that would only tell us, so if I was to find that slope, it would be like that. Well, we can see that the slope doesn't quite equal what the actual slope at that point is. But he said, but if I make x closer, right? So if we were to, let's just zoom in onto this point. Okay, so say that was the slope. Between here and here, the slope's quite, well, it's not that accurate. But if I was to do it here and here, it would be even more accurate. So as this point, as h gets smaller, the slope gets more and more accurate to what the slope would truly be at this point. And he said, well, what if I just make h 0? Well, he did that. And of course, when you divide by 0, you get an undefined answer. But he said, well, let's do it anyway. And so he said that we'll just say that this is the formula, but we'll say limit as h tends to 0. In other words, we'll make h 0 and we'll figure out what the slope is at that instantaneous point. And that is first principles. Now, it doesn't work straight away, because if we just plug in 0 into our h, we're going to divide by 0 and get an undefined answer. But we've got the basis of how we're going to now solve this. And so the way we use first principles is to say, first, we have to get rid of that h at the bottom. Then we will put into place this brilliant solution that Newton figured out. So this is how it works. So this formula here is basically the only thing that you need to know. So everything that I've gone through now, if you didn't understand any of it, that's okay. This formula gets given to you at the end And so you can just see that this would find the slope at a single point. But it's not important that you know this graph or how Newton did it, but it is fascinating and very clever and quite simple, but brilliant. So now what we're going to do is we're going to use this formula. And so this formula you get at the back of the sheet, so you don't need to remember it, but you just need to use it and know when to use it, and you'll see. So let's look at an example. So what you would do is in an exam, they would say, find the derivative of x squared minus 2x using first principles. So we already know the answer because from our power rule, we know that f dash of x is equal to 2x minus 2. So we already know the answer to this question. So it's like if you see this and with the 5 marks next to it, you know that you're going to get these marks as long as you remember how to solve for first principles. So the first step is we write out the formula. So limit as x tends to 0 of f of x plus h minus f of x all over h. Okay, so that's the first step. Now what I'm going to do is I'm just going to say, well, we know that f of x, this bit here, so let's put this bit in yellow, or just say yellow. So that is the yellow bit there. That is f of x. Now, f of x plus h, I'm going to do in light blue. And so all I'm going to do is wherever I see an x, I'm going to put an x plus h. So that'll be x plus h squared minus 2x plus h. So that's the blue bit. Okay, so now I'm ready to go. Limit as x tends to 0 of f of x plus h is going to be x plus h squared minus 2x plus h minus f of x. So f of x is this bit yellow. Oops. So I've just replaced the f of x with an x squared minus 2x all over h. Okay, so far, very simple, just followed the steps. Now I write it again, limit. So this is h tends to 0. H tends to 0. Limit as h tends to 0. Now I'm going to just times this out. X squared plus 2xh plus h squared is this when I times it out. You can do it on the side if you're not sure how I did it, but you would just say x plus h, and you should know how to times this out. Minus 2x minus 2h minus x squared, minus a minus is a plus 2x. And what should always happen is the x squared, everything without an x should go away. And it does. All over h, and I'm left with limit, I write again as, by the way, you have to write limit as h tends to 0 all the way through. And then I'm going to write 2xh plus h squared minus h all over h, limit as h tends to 0. Now what I'm going to do is I'm going to take out my h, because if I take out my h, I can then cancel the h at the bottom. Uh, 2x minus 2. Oh, this was minus 2 times h is minus 2h. 2 times h is minus 2h. Then, so this is a, see, I already knew when I saw minus 2 that it had to be a minus 2 here. So you can go back and find, that's why you're going to guarantee the marks, because you know the answer is that. By the way, you don't write this out. Don't put the answer, because this is not using first principles. This isn't just so that you know when you see this, you've got the answer right. All over h, and the h's cancel. Now, I'm going to substitute, and I'm not going to write limit as h tends to 0. Now I'm going to put in the h as 0. I couldn't put it at the beginning because I get an undefined answer when I divide by 0, but I can now because the h at the bottom is gone. And so then my final answer is going to be 2x plus 0, which is goes away, and I end up with 2x minus 2. And so you get 5 marks just for following the steps correctly. Okay, so that's limits as h tends to 0, how Newton figured out how to find the instantaneous rate of change on a graph. All you need to do is follow these simple, easy steps, and you should get 5 marks when this one comes up. So hopefully that helped. If it did, please like, subscribe, and all that good stuff. And I will see you in the next lesson where we'll be doing some more differentiation, or finding the derivative and the types of notation and questions they could give you. And after that, we'll be doing cubic functions and optimization, and then we'll be done with calculus.